Now our topic is work. See, work comes from force, right? Many times we are pushing some object and that object get displaced. But somehow we push wall, right? Wall never displace. So question is, work is done in that example or not? Actually work is not done, but still I have to use my energy drain whenever I am pushing the wall. So I am trying to push that wall for half an hour or 1 hour. My all energy will be drained, right? So work is not done yet, but still somehow my energy gets drained. So where is that energy gone? So that energy gone within my body as a muscular energy. So it develops my muscle. When I push the wall, it develops my muscle. So energy is gone in the form of restoring in my body. So in that example, no work is to be done, right? So there is a work, no work of first example. Now second example, if we lift something for an half hour, our energy will be drained, right? But still work is not done. So energy is consuming by that object to lift that, but work is not done yet, right? So that is second example of no work. Still we are pushing, we are giving force, we are giving our effort. So that is work, actually no work. So lift force, no displacement, no work, right? Second example, if some girl is just pulling one car with this string, so that cars moves in same direction which she pulled, right? So in that example, when girl giving a force to that car, by that force that car just displaced. So at that time we can say that work is done. But that is also depends on what force we are taking, whether it is frictional or effort force. So work is also depends on the direction of force as well as direction of displacement. So we have to uh, focus on the two terms: direction of force, magnitude of force, similar direction of displacement, magnitude of displacement. Total four factors are there mainly, but from that mainly we are having two factors for work to be done. First, force, and second, displacement. So these are main factors of the work. Now, to know this work phenomenon, I am taking one more example. If we are having one block on this horizontal surface, now that block having mass m, right? Now if I am pushing that block in this direction, so force is applied in this direction. Now if this block displaced by s, then work is to be done on this object. Otherwise, if no displacement, s will be 0, then work is also 0. So work just follows this formula, force into displacement. So here force and displacement both are in same direction, right? So to know this work, force multiply with this displacement. Now in this particular example there are three more cases for this. See, always work whole equation is, here it is dot product means cos theta, right? So f into s both are in same direction, that's why I have to write cos 0 will be 1, that's why f into s. Now second example, if we are having force which is in downward direction, and displacement in right hand side direction. So to find work, now again same formula, Fs cos now 90 degree, because they are making 90-degree angle. Cos 90 will be 0. So no work is to be done. So remember that whenever force and displacement both are perpendicular, then no work is to be done. And third example, I am taking that same. Whenever we apply external force in this direction, there will be frictional force here, and displacement again in that direction. Both are opposite. I have to write here W is equal to F into S cos. Now whenever both directions are opposite, we have to take angle as 180 degree, and cos 180 will be minus, so minus F into S. So that is work done, which is negative. Why? Because both are in opposite direction. Here they are perpendicular, that's why 0, and here both are in same direction, that's why we are getting this work, which is maximum here. Minimum we get here when they are totally opposite with each other. So that is our work phenomenon. There may be energy consumption, but due to energy consumption, there is nothing permanent that work is to be done whenever energy consuming by the object. There may be work is equal to 0. So it depends only on force as well as displacement. There may be only force. If displacement is 0, work is 0, right? But with the displacement, there is always force which is exerted on the body. But see, if force is also 0, force can also 0 whenever that object will be moving with uniform velocity. With uniform velocity object, force is 0, displacement is also there, and also at that time work will be 0. So work is depending on these two factors.